Okay, in this video we're going to look at compound interest, and so we've got a different formula from the simple interest, and just as a way to sort of explain what compound interest is, say so this is simple, say our time period was 5 years, and every year for the period of that 5 years they worked out how much interest was earned in 1 year, and then they added that into the account. So compound interest is kind of like simple interest, except at shorter periods within the length of the investment or the loan. A small amount of interest is calculated and it's added to the principal, so that for the next period of time, the interest being earned is actually on the principal plus that little bit of interest. And so the more times a little bit of interest gets put into the account, the principal is essentially increasing each time. So simple interest, it's called simple because it's, remember we said it was a flat rate, so that the interest amount is worked out over the full period of the loan, whereas compound is, don't worry about the formula, it's essentially repeated layers of this for shorter periods of time, and the principal is increasing each time as we keep adding the interest in. So every time we calculate the next lot of interest for that period of time, it's a little bit more. Okay. Hopefully it'll make sense. So this is the formula. Got a few different letters in this one. So we've got A equals P multiplied by this thing, which is just a 1, plus I, and then this thing in the brackets is raised to the power of n, and that just means it's this thing in the brackets multiplied by itself n times, whatever that number happens to be. And this n can get quite big. So A is the amount in the account after n interest-bearing periods. So whereas simple interest, the formula worked out just the interest, and we had to then add it on to the principal to work out the total. This is the total. It does it for us. It's packed into here. So P is just the principal amount that we start with again. I here is the interest rate per period. So essentially what that means is compound interest, it could be once a month or quarterly or once every 6 months, or it could be daily. They calculate the interest. So we're normally given the rate as an annual rate, and then we have to work out how often that happens per year, and I is essentially the annual rate divided by how many times per year. And this number n is the number of interest-bearing periods, so that's usually the number of times per year that the compounding happens multiplied by the number of years. So it'll make sense once we start doing a few examples. Okay, so I'm going to get rid of this. We'll keep our formula, and I'm just going to jump straight into an example. So this is the 3.5, and I just sort of want you to get used to substituting numbers into this, and then we will have a look at a few different ways that these compound interest questions can be. Okay, so this first question, $5,000 is invested into an account which earns 9% per annum, that means per year, and it's added quarterly. There's extra information in these questions that we need to work out what numbers we're plugging in. How much is in the account after 8 years? Okay, so what I'm going to do up here is we're going to I'm just going to list what we know to our principal. That's the $5,000 that's invested. That's just the one. I, in this case, we're turning this into a decimal. And it's added quarterly. So quarterly means we're dividing the year into 4. But this is for a whole year. Per period, we just need to divide that by 4. So when I substitute I'm going to write 0.09 over 4. Now n is the number of times per year multiplied by the number of years. So we've got 8 years. It happens 4 times per year. 8 and 8 is 16, 16 is 32. So our n is 32. Okay, so now I've worked that out, we can plug the numbers in. The amount in the account equals $5,000 multiplied by 1 plus 0.09 over 4 to the power of n, which is 32. Okay, so when I type this in the calculator, I'm going to put probably this bit first. Then I'm going to add 1 to it. Then I'm going to tell the calculator to multiply this 1 point something by itself 32 times. And then I'm going to multiply by this. Just so that I get my order of operations correct. So I'm just going to do this one step at a time. 0.09 divided by 4 is 0.0225. It's easy just to add these because that 1 just pops in there. 1.0225. So we need to take this number and raise it to the power 32. On your calculator, you might have a button that says the Y, or you may have a button that just has a thing like that, which is like a little up arrow, which means you press that and then you're telling it that you're putting in the power. But that's understanding your calculator. So now I'm going to type in 1.025 to the power of 32, press equals, and then multiply it by our principal. So finally, after 8 years, we have $10,190.52. Okay, so the next question, same sort of thing, except these numbers will change. And I'll do that. See what's going on. So this question, find the total amount of interest added. So because our A is the principal plus the interest, but only want to find the interest, we work this out and then take our original principal away. So find the total amount of interest if $650, 5 years, 4.8%, compounding monthly. So the compound is where we add in that little bit of interest, and the principal, well, not this principal, the simple interest principal grows a little bit. So each month we're earning a tiny bit more interest as it gets added in and added in. And this so compounds monthly. That'll be 12 times per year. We've got our principal. Let's just write this up here. The interest rate is this as a decimal. It's per period, so we need to divide that by 12. And N, we've got 5 years, and it's 12 times per year, so our N in this case is going to be 60. 5 times 12. Okay, so let's start writing this down. The amount, so that's interest plus the principal, equals 650 times 1 plus this number. All to the power of 60. So again, I'm going to type this fraction first, then add 1, then raise it to the power of 60, and then multiply it by the principal. If you have a calculator where you can just type it out exactly like that, great, do it like that. Okay, 0.048 by 12 plus 1. So write this down. 6. So after we've calculated this and added 1, it's 1.004. Answer to the power of 60 times 650. So we've got $82.92 in the account. So that's the original principal plus the interest. So this question wanted us to work out the amount of interest. So we're not quite finished. So the interest we want to take away the original principal. Interest is down here, so that's 7. So we earned $175 interest in $75.92 under these circumstances. Okay, so let's have another question, and this question asks us to calculate 2 separate situations comparing different compound periods. So hopefully you'll see that the way things work out. So in account A, do it in blue. A, we've got $1,500 invested for 5 years, 8% interest per annum, compounds annually. So that's just once per year. In account B, same thing, $1,500, 5 years, at 8% per annum. And this one compounds monthly. It might even, just as a bonus question, be worth working out the simple interest. So our interest. So this would be with no compounding. So let's go. T equals 5 years. We'll do that last, just to see what happens. Okay, so I'm just going to jump straight in. Plug these numbers into our equation. So the amount equals 1,500. 1 plus 8% divided by once per year. I'll write it in there. And the number of compounds, 5 years multiplied by once per year, that's the power of 5. I'm also going to write this one out so you can see what's different. The amount 500, 1 plus 0.08. So this one is over 12. So this number is different. And because it's 12 times per year for 5 years, n is going to be 12 lots of 5. That's 60. Okay, so actually let's just replace that with 60. So the number at the bottom of the fraction changes and the power changes. So this number in here is smaller than this number here. Because it's multiplied by itself 60 times compared to 5 times, I think we're going to end up with more money in this account. So the first one, 15000, actually 1.08. So in this account, we end up with $2,203.99. Wasn't too hard. In this one, 0.08 divided by 12 plus 1, the power of 60, and multiplied by 500, we end up with 2,234.77. So it was the same amount, for the same length of time, the same rate. The only thing that was different was how often that little bit of interest was added and put into the account. So because this one compounded monthly, we ended up with about $30 more, just over $30. And that's because although each monthly amount of interest was smaller, it got added in to the account, which meant that that small amount kept growing each time. Okay, I think it's probably worth, let's see what happens if we don't have any compounding. If interest is just worked out for the entire 5 years, and we just work out 8% per year. So this would be 1,500. 5. And we get $600 interest. So the amount in the account, I'm just going to write it like this, is those two added together, and it's just $2,100. So compared to simple interest, same amount, same rate, same number of years. Because this was compounding at a slower rate and this was compounding quicker, this one ended up earning a whole lot more than that. This one a little bit more. So hopefully that makes sense why this one ends up earning the most. Even though this number is smaller, it's being added in many more times. Okay, so we've got one more example. And this one, we may have to rearrange our formula. So like we could rearrange the simple interest formula, we can rearrange easily to be able to work out the principal. To work out these ones, kind of a bit tricky. And I think we'll maybe work out how to do that using the fancy calculators. Okay, so the last little example, how much needs to be invested? I'm going to put in brackets. So that is our principal. How much do we have to start? At 8% per annum, compounding twice annually. So let's just say 2 times per year. For final amount to reach $2,500. So this sort of question, it's like saying, I want to go on holiday in a certain amount of time. Oh, used to be that in 3 years. So it's basically saying in 3 years' time, I want my investment to have reached this much. How much do I need to invest now under these circumstances? Compounding twice per year, this rate. How much do I need to invest now so that in 3 years it reaches this? What I'm going to do is I'm just going to rewrite this . So this is principal multiplied by this big chunk equals this. So if I want to work out, if I know what this is, and I know these numbers, I'm going to divide both sides by this whole thing. 1 plus I to the n. So that whole thing cancels out with that. And we end up with, so this is a rearrangement of this formula. I'll write this one in red. The principal equals the final amount divided by 1 plus I to the n. So this allows us to work out the starting principal if we know how much we want to reach. So this question here, the blue, the principal equals, so the final amount, 2,500. Divided by 1, so the interest rate is 0.08 twice per year divided by 2. And our n is the number of periods. So we've got 3 years, and it happens twice a year, so that's going to be 2 times 3 is 6. So our principal equals. So be careful on your calculator. You've got a whole, it's this divided by that whole amount. So if you type things in the wrong order, you could end up getting a weird answer. So I've calculated this bit to the power of 6. And because my calculator has an answer button, I can now say 2,500 divided by the answer. And we get 1975 times by 0.79. So if I want a compounding twice per year, 8% per annum account to have this much in it in 3 years' time, I need to put this much money into that account now to allow this to grow to that.